So C4 is all about chemical calculations, and the first thing that we need to know is relative atomic mass, which is the value of the mass number of an element, so the larger number. So it's the total mass of the protons, neutrons and electrons, which we know is almost zero. It is actually the mass of an atom compared to carbon-12, and its symbol is Ar. Chlorine's 35.5 is due to its isotopes. And as we looked at in the last video, relative atomic mass is also equal to the sum of isotope abundance times isotope mass divided by the sum of the abundance of all the isotopes. If this is given as a percentage, this value would be 100. The next thing to cover is relative formula mass. This is essentially the total of the relative atomic masses added up in the ratio shown in a chemical formula. The symbol for this quantity is Mr. For example, hydrogen iodide. The Ar of hydrogen is 1, the Ar of iodine is 127, so the Mr would be 127 plus 1, which is 128, and it's really important that we understand that both Ar and Mr have no units. And then we have the mole. The mole is simply the relative formula mass in grams. The mole of any substance contains the same number of atoms, 6.02 times 10 to the 23 per mole, and this number is called Avogadro's constant. The units of moles is mole, and moles equals mass over Mr. Our mass is measured in grams, remember, for chemistry. So the mole is simply a measure of an amount of something. So for example, if we were asked to calculate the number of moles in 11 grams of magnesium chloride, we'd use the equation moles equals mass over Mr. We have been given the mass in grams already, that's 11, and now we need to work out the Mr. However, we might not be given the formula magnesium chloride, so we'd need to work that out by identifying the charges. Now we know by looking at the periodic table that magnesium is in group 2, so it's going to form an Mg2 plus ion. Cl, chlorine, is in group 7, so it would form a Cl minus ion. We need to balance out those charges, so we'd make MgCl2. Now we need to identify the Mr for MgCl2. So we've got 1 lots of magnesium, the mass number of magnesium is 24, the mass number of chlorine is 35.5, but we need to times that by 2 because we've got MgCl2, we've got 2 chlorines, and that would bring us to a total of 95, so we'd do 11 divided by 95, and that would be 0.12 moles. However, there is another scenario when moles are applicable, and this is when we are given a balanced symbol equation. For example, H2 plus Cl2 makes 2HCl. Now, to identify our moles, we look at the big numbers. And remember that if there is no number in front of an element, we can assume that is 1. So we'd have 1 mole of hydrogen, 1 mole of chlorine, and 2 moles of hydrochloric acid. We only use the big numbers to identify how many moles we have, and we use the small numbers to identify our Mr. So Mr and mass on each side of the equation are always equal, and this is the law of conservation of mass. Now, some reactions may appear to have a change in mass. This is usually explained because the reactant or the product is a gas. A more likely exam question is being given an equation, for example, 2H2 plus O2 makes 2H2O. Calculate the mass of oxygen that must be needed to make 45 grams of water. Now we use our equation moles equals mass over Mr. But first we have been given the mass of water, so we're going to work out the moles in our water. So we're going to do 45 divided by the Mr of H2O, which we add up, 16 plus 1 plus 1. So 45 divided by 18, and that would give us 2.5 moles. Now we're going to write out the ratio of our moles in the equation. So if we look at the big numbers, we can see we've got 2H2, we've got 1 O2, and we've got 2H2O. But we're only interested in the oxygen and the water, so we've got 1 to 2. Now we know that we've actually got 2.5 moles of water. If we want to make 45 grams of water, that's 2.5 moles. So we now compare that in the ratio. If the ratio is 1 to 2 and we've got 2.5, we need to half that to get to the 1 part, the oxygen part, so that will give us 1.25 moles. We've now got our moles, but we want the mass of the oxygen, so we rearrange the equation moles equals mass over Mr to mass equals moles times Mr. We slot in the moles, 1.25, we work out the Mr, which is 16 times by 2. And we work that out together, and that would give us 40 grams, and that would be our answer. Now, a little note here, if the ratio of the moles is 1:1, then we don't need to change anything. It can stay the same. I'm now going to just sort in an equation that pops up all over the place in science exams, and that is the equation for uncertainty. Uncertainty equals plus or minus the range of values divided by 2. Please learn that. It's so important. And then we have the topic of empirical formula, which is basically the simplest whole number ratio of something. For example, the molecular formula of glucose, which you might know from biology, is C6H12O6. To obtain the simplest whole number ratio, we divide each of the components by 6, which would bring us to CH2O. And that would be our empirical formula of glucose. Now, an exam question might look something like this. A compound is 11% hydrogen and 89% oxygen. Calculate the empirical formula. Here we've been given the percentage mass, so we can find the moles. Moles equals mass over mR. So for hydrogen, 11 divided by the mR of hydrogen, which is 1, equals 11. 89 divided by the mR of oxygen, which is 6, 89 divided by 6 is 5.56. Now, to obtain the whole number ratio, we need to divide by the smallest number, which is smaller, 11 or 5.56. It's going to be 5.56. So 11 divided by 5.56 is almost 2. 5.56 divided by 5.6 is 1. So we've got almost, so essentially 2 lots of hydrogen, 1 lot of oxygen. So our empirical formula is going to be H2O. Now, as we've just seen, empirical formulas are generalizations. And I'm just going to pop in here the idea that if we had Mg plus H2SO4 equals 10 grams, then MgSO4 plus H2 is 10 grams. Now we're going to move on to limiting reactants, which is for higher tier only. Just to check that you know what a reactant is, a reactant makes a product. So in a chemical equation, reactants are found on the left side of the arrow in that equation and products are on the right. In chemical reactions involving 2 reactants, it's common to use an excess of 1 to ensure all of the other reactant is fully used up, which is the phrase to use in your exam. Now, the reactant that is fully used up is called the limiting reactant, and this limits the amount of products made. The other reactant is said to be in excess. At the simplest level, a question might state there are 5 moles of magnesium mixed with 7 moles of sulfuric acid, which is in excess, and how many moles are formed. In our equation, Mg plus H2SO4 makes MgSO4. We have 1s in front of all these numbers, so we've got a 1:1:1 ratio, which means that we can just slot 5 to 7 to 5 in without changing anything. Now, which is the biggest? Which do we have the most moles of? Well, that's H2SO4, sulfuric acid, so that one's in excess. Now, that means that Mg is limiting, so that's a limiting reactant. So a limiting reactant limits the amount of products that can be made. So if we've only got 5 moles of magnesium, we can only make 5 moles of magnesium sulfate. However, a question is more likely to look like this. 10 moles of iron oxide reacts with 50 moles of carbon monoxide. Calculate the moles of the products. The equation will be given to you in the exam, which in this case is Fe2O3 plus 3CO makes 2Fe plus 3CO2. Now we're going to identify the molecular ratio by looking at the big numbers. So that would be 1 to 3 to 2 to 3. So if we just look at our reactants, that ratio would be 1 to 3, and we know that we are reacting 10 moles of iron oxide. So if we put 10 in under the 1, we've got 10 moles of iron oxide. In that ratio, we're going to need to times that 10 by 3 to identify how much carbon monoxide we need to react with that 10 moles. So 10 times 3 is 30. So we'd need 30 moles to react with that iron oxide. We've actually got 50 moles as per what the question has told us, which means that we've got more than enough carbon monoxide. So the carbon monoxide is in excess. Now, because the carbon monoxide is in excess, that would mean that the iron oxide is our limiting reactant, which will limit the amount of the products formed. So now we're going to look at our ratio again. To get to our products, our ratio is 1 to 3 to 2 to 3. Now, because our limiting reactant is 10 moles of iron oxide, we're going to put 10 in there. So we need to times that by 2 to see how much iron we'll make, so that would be 20, and times that by 3 to see how much carbon dioxide we'd make, which would be 30 moles. Now, if we just wanted to find the mass of these products, we'd only, simple as this, we're just going to use mass equals moles times mR. The last real topic is expressing concentrations, but there's a few quick terms I want to discuss first. A solute is simply a soluble substance, and we can picture this by imagining we're making squash. In this case, the solute would be our squash, the solvent would be the water, and the solution is the solvent and the solute mixed together, so the water with the squash mixed in. And concentration is simply how much solute is dissolved into how much solvent. Concentration can also be written by the shorthand as seen above, and there are two quick equations that we need to learn off by heart for concentration. The first one is that concentration equals the amount of solute in grams divided by the volume of the solution in decimeters cubed. The second one is that concentration equals the amount of solute in moles divided by the volume of the solution in decimeters cubed. And we can use mass equals moles times mR to distinguish between the two equations. However, just to be mean, they might give you the volume of the solution measured in centimeters cubed, and you need to change that to decimeters cubed to be able to use our equations. So to get between centimeters cubed and decimeters cubed, you divide by 1,000. Now, probably the hardest question they could ask you would be something along the lines of this. Express the concentration of 25 grams of hydrochloric acid dissolved in 250 centimeters cubed of water in moles per decimeters cubed. Now, the first thing that we notice is that they've given 250 in centimeters cubed, and we need that in decimeters cubed to use our equation. So 250 divided by 1,000 is 0.25 decimeters cubed. The next thing that we notice is that HCl is in grams, and our final solution needs to be in moles per decimeters cubed, so we can use the equation moles equals mass over mR, which we use to distinguish between the two equations. We've been given our mass is 25, so 25 divided by our mR, which we can find on the periodic table by looking at the mass numbers, adding them up, gives us 36.5. 25 divided by 36.5 is 0.68 ... Back to our equation, concentration equals amount over volume. 0.68 ... divided by 0.25 gives us 2.74 moles per decimeters cubed, and that is our final answer. The final note I want to make is when we mix standard form with significant figures, an example being 1.8 times 10 to the 2. This would be considered rounded to two significant figures. This is because the 1 and the 8 are significant figures, but the 10 to the 2 is not. So it's the number before the times 10 to the whatever which counts as the significant figure. And that's all C4, so well done if you made it to the end, and see you next time.